So I'm Clive Sabel. I'm a professor of something called spatial epidemiology, but you probably don't need to know that. But what I'm doing today is I've had my arm badly twisted to present some work from our colleagues in India. I know them, I've met them, but I've got to say this is not my work, and I feel rather uncomfortable presenting somebody else's work. But we have got some people, although half of them have left, behind me, so I've been left alone, who can answer some questions if we do have questions at the end. But first of all, I just want to play a video by Professor Krishna, who would have been here if he'd been able to get the visa today. So to play the video, do I just press forward? Yep.
Hello, good afternoon. I am Professor Krishna Vasudevan from the Department of Electrical Engineering at IIT Madras. I am happy to be delivering this talk as a recorded talk. Unfortunately, I could not join you physically for the meeting. So let's go ahead and I'll share my screen to do the presentation.
So in place of Krishna, I'm going to give you a quick 10 minutes. He was going to talk for 28 minutes, and I'm going to give you the short version of it. What I have been struck by as we've been hearing the experience from Central Australia from the previous speakers is how complementary the work, the case study in India actually is. We'll be talking about microgrids, and we've heard a little bit about the implementation of microgrids here. And we're going to see how parallel the experience is in India. So I'll start with stating the problem as we experience it in India today, often for very remote communities, so obvious parallels to here, that are not on an established power grid. Often the cost of laying power lines to a remote Indian community is too expensive, or the returns on the investment for a company are too low. Often this can also be exacerbated by a problem of unsteady or unreliable power from a central grid. And so lots of communities in India are starting to see the advantage of establishing their own microgrids, just like here. But the needs are perhaps a little bit different. The needs are firstly and most importantly around lighting, simply providing light in the home. Cooling, as we heard just now, also applies. And as Satiris highlighted earlier, cooking is an important new form of electricity to remove the more damaging forms of solid cooking. So often it was wood, I believe, in India, to have a cleaner environment for cooking. And then things that are a little bit more closer to my home area, I feel more comfortable talking about. Things about enhancing the ability for children to educate in the home at the end of the day. So they can do homework or they can take online courses if they have communication methods that are powered by electricity. So this is not just about providing electricity for basic requirements, but it's about enhancing rural communities to compete with their urban counterparts in terms of getting an equitable education. Now, the solution for the rural communities that we've been working with in India are very similar to the range of possibilities here. The sun dominates, so PV, but also heat to directly heat water is one solution. Wind, but only on the coast in India is a viable solution. Biogas and waste from the local communities are also used. The two key points are to engage with a microgrid, but do it through a community partnership. And again, that talks to what we've heard about this just now from the experience locally here in Australia. But the first question probably some of you are asking is what do we mean by microgrids? Because it can mean different things in India compared to locally here. So at the really simplest level, what we just saw in that community just now is one house with a PV set up on a house. That is the smallest microgrid that we might be considering. But in India, they're often talking about a community, a village that creates their own microgrid, potentially with one source, so PV or diesel power, but more often than not with a range of input electricity generators to provide resilience for different environmental conditions that could hit. So, for example, if there's no sun, a diesel backup is available. Microgrids are a naturally resilient system. They do not rely on any connection to the wider world, and in a changing climate, with as we've been hearing earlier today about the Lismore flooding and other natural disasters that are happening more and more, a microgrid actually provides local communities with more resilience rather than less. Go back. And an important point in India is to note that it's not necessarily a green solution. As we'll see in a minute, many of the solutions are far from green. But of course, the transition and the movement and the project that Sotiris is setting up is to try and create this green solution in India too. So from a quick survey of that my Indian colleagues have done, across many parts of the world, from India through Denmark, where I used to work, and then you can see through the United States, Canada, the UK, Chile, China, Japan. There's a wide variety of a survey of about 570 different installations, microgrids. They use a vast variety of different sources along the x-axis there. DG is diesel, PV, photovoltaic, battery backup, fuel cells, natural gas, a combined heat and power is another source. Wind, of course, is important. Hydroelectricity, biogas, or a steam turbine are other ways of using it. And you can see on the y-axis the power capacity of these different systems, and you can see that diesel, natural gas, wind, and steam turbine are the four biggest producers of electricity. But the color of the bars shows the variety of the different microgrids setups around the world that use those particular things. So you can see only a few use wind or steam turbine or natural gas, when many of them use diesel or photovoltaic. And then if we go on to India and a little bit in Malaysia here and Haiti. On the left-hand side of the pie chart that you see here, we see that photovoltaic make up the vast majority of installations, but in terms of generating output, you can see on the right-hand side that diesel, although has only one or two installations, they have a lot more generating capacity. So that's an interesting phenomenon happening in India, there's micro generation of photovoltaic, and the bigger ones are more established diesel or a little bit of wind and diesel combined. So what's the experience of microgrids in India? Well, first of all, there's one big advantage compared to what they're used to, and that is that they provide power 24/7, so 24 hours a day, 7 days a week. And that they are using it largely for lighting, as I said at the beginning, but more and more to enhance their lives, to bring the rural communities that they've studied in India up to the equivalent of the urban environment in India and perhaps also in Australia. So, for example, using entertainment and communication. So people can have Wi-Fi in their house, they can watch YouTube if they really need to, and so on, such long. Larger consumers, perhaps richer individuals, tend to use installed diesel generators for themselves. Okay, the smaller ones tend to use photovoltaic. The improvements are obvious, as we talked about before. The indoor environment is less smoky from cooking. That's a big improvement. And of course, that directly affects parts of the family more than others. So the people who would tend to be cooking, as Satiris mentioned earlier, tend to be the women in India. And so that directly helps them. Of course, once there's a supply of electricity, there's an increase in demand for that electricity. So that is actually quite difficult for planning purposes. You might try and design a system that meets the current demand, but as soon as you install it, demand doubles. And that's something that people have to take into account up here as well, I believe. So lighting, cooling is very important in India. An increase in study time. So teachers are reporting benefits that they can see in the classroom, that the students are doing better because they're able to study because they can see in the evening to do their homework. And we shouldn't discount that important thing. The final one, sort of rather cryptically labeled, increased time for livelihood. Increasingly now, we live so much of our lives online. We're saying that people in India need to do things like online banking that they couldn't do before when they didn't have electricity, or that they could pump the irrigation in their fields for longer at night when electricity previously would have been not so reliable. So it's direct benefits for the family or for their education. There are a number of different solutions for installing microgrids in India. There are different models. Either the government can install it through a grant system, but more often than not, there would be a commercial company would install the system and then rent back the system to the people who use the electricity, and they can do that very much like in Australia. We can do it on a prepayment meter, or they can rent for a monthly charge. Or increasingly, the bottom option there, build and transfer, is becoming more and more interesting. So perhaps the government or a company would build it, pay the upfront capital costs, and then transfer those costs to the users, and then the users become the owners of their own system. And that is a very interesting model that I think might work really well here. Of course, the financial model needs to be very carefully looked at. And the degree of subsidy there is an important question. What can the local government or the central government afford to subsidize, and what can the local population afford to take on? So there are some problems that they've experienced in the case studies in India. One of them is about non-participation. You can live in a community that has a microgrid, but there's no compulsion that you use that. That in itself might not be a problem, but what happens at some point if, say, the national grid or the regional grid also comes to the village at the same time or immediately afterwards? Often the national grid can provide electricity for a lower unit cost, and then the local microgrid is uncompetitive. When they've also had a large capital cost to install the microgrid, that obviously can cause problems. So these more political processes need to be thought through. You can interrupt me at any stage.
This is very interesting because, you know, under the Aboriginal Land Rights Act, the Territory Government also have some they pay a royalty to Indigenous people or to the Land Council, who then distribute it to the traditional owners, where government have got houses on the communities. And I'll just, when you were talking about people willingly participating in that system or
Maybe
Sorry.
take them up.
I'll pull the mask down. Is that better? Yeah, sorry.
Okay.
So the legislation around and what we've heard from Veronica before about Tennant Creek and the issues around legislation is going to be problematic in terms of getting systems built in communities where existing government buildings are in place, infrastructure, and how when there's new community, like down here in Alice Springs, Minister Eubo's just put in a number of houses, and what sort of power grid is that linked up to? Are they looking at renewable energy? Are they going to, and if they haven't, are they going to, and what sort of costs will that imply for the government and for communities? So, and what will the role of the land councils be in that process? So these are all the sorts of problems that you've just identified in India, but there are all these multiple layers here as well.
Yeah, I've got to get I move on. I'm totally aware of the time. I'm so sorry. Yes. To summarize, the politics become so important, and the security of the contract becomes so important in the Indian context, and also applies here. So just move on to my last slide. Clearly, there is a social benefit to having electricity in local communities. There are clear advantages in terms of resilience of the supply, but the politics are the key point. Having, from my knowledge, a decadal contract with a supplier, whether that is off your own roof or from a local microgrid, is important, because you can't invest for the long term when the capital cost, the repayment on your roof is what, 15 years, something like that. If you're making a 15-year investment, you don't want to be undercut in 5 years' time by another system. So then that's the kind of thing that needs to be really negotiated through, and they saw this in India as well. So I'll stop talking. Thanks very much. Thank you.